Today we're going to be discussing how to use driver performance metrics to improve battery electric bus operations. My name is Ryan Mackham. I'm a business development manager at Innit. My specialization includes electric transit buses in the public transit environment and onboard data collection from those vehicles. So today we're going to be going through a brief introduction, and then we're going to dive into the specific driver impacts on vehicle efficiency, followed by an example of what a driver assistance system would look like that you'd use to achieve the overall goal we're discussing today, followed by the positive case for driver assistance. So for those of you who have heard this before, some of you I'm sure have, in 2019, Innit launched in North America our electromobility program with the purpose of supplying transit agencies with all the tools required to assist in a seamless battery electric bus conversion. These products focus themselves in several realms, including planning and scheduling, smart charge management, real-time fleet management, and of course, what we're going to be talking about today, the one at the bottom left, which is consumption analysis. And why are we talking about consumption analysis today? Well, for those of you guys who have been on these webinars before, you know I like to do them to try to alleviate as many headaches possible for you. And probably the biggest headache when it comes to electromobility is range anxiety. And yes, it obviously does exist. And so the thing with range anxiety, though, is it is a very complex issue. And this complex issue touches on many different aspects and in many different parts of a public transit agency's operation. And then today we're going to be focusing on what I view as one of the least discussed, highest impact problems that you're going to run into, and that is driver behavior impacts on the efficiency of your electric vehicles. So why does this matter? So straight up, uneconomical driver behavior can reduce the range of an electric vehicle by as much as 20 to 30% while in operation. And so for those of you joining us today that are in climates with high amounts of temperature fluctuation, it's very likely that you'd be on the higher end of that spectrum. And so not only is this impact huge, but this is going to be further amplified by other operational conditions that affect the range of your battery electric buses, such as the weather and the weight of the passengers. Of course, a bus with 5 people on it is going to be able to go faster or further, I'm sorry, than a bus with 40 people on it. Transit providers can save themselves huge headaches and major energy costs by implementing systems that can track and monitor these metrics and alert you when drivers are engaging in a behavior that will negatively affect your range. Some specific metrics that can impact your efficiency. So one on top, harsh acceleration. So a lot of you guys, if if you're familiar with the private car market, you'll know that they have like an eco mode or a green mode that will allow you to, kind of gradually accelerate from a stop. And the reason that is because this is a huge battery drain. The second one, harsh braking events. So I kind of want to take a pause here to emphasize the difference between a harsh braking event and, letting your foot off the pedal so that your regenerative braking can work. Harsh braking, when you slam on the brakes, that's not regenerative braking. You're using the hydraulic brakes. They're creating heat and that energy is being expended and wasted. Those are not the same thing. Vehicle idling, of course, if the electric motor is engaged and the vehicle is not doing anything, then that should be something that is tracked and limited. General speeding, if you're going faster, you're going to use more energy. I think everyone here can pretty much agree that that's important. And of course, last, harsh turns and or G-force indicative events. Okay, so what I'm going to talk about now is some examples of what you guys would need to look for in the driver assistance system for your electric buses. So first off, what is it going to do? At its base, the driver assistance system is going to be used to create an energy consumption profile for your entire transportation network. So, this would be diesel buses, this would be electric buses, but the core functions of this would be to improving efficient driving through database driver training and positive reinforcement. I'll talk about that a little bit more later. Second item, real-time driver feedback during operation, which would take place either on the mobile data terminal currently present on your bus or via a separate device if one is not there. Followed by automatic report generation for the drivers and even specifically the operating companies that would be responsible for them. Okay, and so the principle behind the driver assistance system is going to be the training feedback loop. And how that works is the driver would receive a real-time alert via the lighted indicator at the bottom of your screen if he is engaging in uneconomic behavior. This would then be compiled and analyzed by the central system applications used by management to come to a conclusion on a training plan that will allow you to continuously improve the driver metrics for the individuals. So another pause here. Usually this is the point in the presentation where people start raising their hands and they're like, hey, Ryan, different drivers do different routes. You have commuter routes, you have urban routes. And so let me just pause to say that there needs to be a particular emphasis on the transparency and the fairness of these metrics that you are collecting. Otherwise, it's not going to make sense. And so to do that, you got to look at, at least these three bare minimum parameters in order to gauge this in a fair way. First one, it's going to be the route profile. You're going to need to gauge the differences in the route profile and block structure for that to be fair. Of course, the reason we're here is you're going to be tracking the number of individual events, which they might be different with the route profile, but those will still be tracked. And the last is vehicle type. Of course, a driver who's driving a 40-foot electric bus, it's going to be very different than a 60-foot articulated vehicle, which would be much different. It's going to be pretty hard, actually. I don't think I can handle that one myself. Just quickly how that would work. So I'm sure most of you know that on board all of the new buses coming out, there's something called the J1939 network. J1939 network is awesome because it pretty much has everything you need on it for electric buses. And long story short, all the different ECU units are going to feed data to this J1939 CAN bus network, which will make it available for your onboard CAT-AVL VLUs. And so if you're an existing Innit customer, this would be your Copilot PC2s or Copilot PC3 computers. Those would then enable the real-time alert to be present on the driver's MDT and then can be exported to the central systems via cellular or Wi-Fi present on board the bus. And so once that cellular data leaves the bus, this vehicle data would then be on an application server where it can be used by the end user applications in order to properly quantify the performance of the drivers. And here, this is just a close-up example of the real-time feedback device. And so just another note for Innit customers, if you guys have, the touchscreen MDT, like I know a lot of you do, then we can just digitally implement these alarms on the MDT itself. You would not need another device, but in case you did, this is what it would look like. And whenever the driver would say, slam on the brakes, accident or not, then that little light would light up right there in the middle, and then you would have that event tracked and logged in the central systems. So here's an example of a pretty simple, pretty high level driver report. And so I think everyone can clearly see here that the ones that are getting, the D's and the F's on their driving report probably shouldn't be the ones to drive the expensive, very, very sensitive electric vehicles. And so the idea would be that you would use the A's and B's in the higher levels of these to currently operate your electric vehicles while giving the other drivers still a chance to improve their scores and hopefully get a chance to participate in this awesome movement as well. Okay, so I'm going to talk a little bit about positive reinforcement for e-bus driver selection. And so, just full disclosure, there are actually a couple questions at the end about this. I know there might be some union rules that might play into account here, but kind of view this as a glimpse into the future, as what you should probably be thinking about as you even go into those union deals in the future. So when electric buses start arriving on site, you have something I like to call the e-bus driver selection conundrum. And so how this is set up is look at it as kind of two sides of a different coin. On one side, in order to ensure efficiency during public transit operation, you need to make an effort to ensure that only the most efficient drivers are the ones operating the electric vehicles. However, when you look at it kind of through a sense of the entire fleet is changing to electric vehicles over time, and that there's a set date for completion for this to happen, you start to realize it's a little bit more complicated. And the reasons that is, obviously generally most drivers would prefer to drive the newer vehicle. Not too surprising, right? And second, the more tenured operators have not necessarily been trained to operate these electric buses yet. And I want to make it very clear that's not a dig on them in any way. This is a completely new technology. There's going to be a learning curve, and that's part of what the driver assistance system will help you do. And last one, and this is probably the most significant one, we are rapidly approaching a time when all future new bus arrivals are going to be electric. So there you see the argument here. So they want to drive the newer vehicles, but then all the newer vehicles are going to be electric. So you have a situation here because the drivers want to drive these new vehicles where you could use positive reinforcement. And so it's extremely important for you guys to realize that the success of your electrification project is going to depend on all the stakeholders within your organization being on the same page as far as the constraints of this new vehicle technology. It is not the same as a diesel bus. It is not a one-for-one replacement yet. We'll see. And so that's something that you need to take into account. And I guess the way that we view this at Innit is that the operation of these fantastic machines is indeed a privilege. And the driver assistance system is there just to do that, to assist the driver in achieving more efficient driving through this real-time feedback, consistent and fair reporting metrics, so that they can put themselves in a better position to do what they want to do and to participate in the global movement behind the electrification of public transit. Like I said earlier, the main idea is the guys with the A's and B metric score would be the most efficient e-bus operators, and that they should be designated to do so. And so I guess another very important point I always try to make here with this is this dialogue must take place in a transparent fashion to avoid the classic big brother is watching you stereotype. This isn't 1984. I know whenever people start thinking about real-time monitoring, performance tracking via central applications and all these different manners, then that starts to be something that can get a little sensitive. However, there is an operational cost-driven reason for doing this. And that reason is that as opposed to, maybe not getting the best value out of the bus from an asset management over the life cycle of the bus perspective, you can actually have a breakdown in operations as a result of uneconomical driving behavior being prevalent in your fleet, which is why this is so important. Okay, little closing remarks here. Long story short, with the many different operational challenges electric vehicles will present you, it's important to realize the significant issue that this will have. Establishing this understanding within your organization with all the relevant different stakeholders will go a long way, combined with positive reinforcement towards achieving the overall goal, which is zero emission, reliable public transportation. And a driver assurance assistance system like this is relatively simple to implement and will provide you with the trackable metrics that you can use to continually improve your driver performance and therefore your operational performance. And I guess, one additional thing here that I'll say is if you're in an environment with, temperature fluctuations or where it's extremely hot or extremely cold, every last bit of energy that you can save is going to help, and every bit will make a difference. And when you start talking about replacing an entire fleet with electric buses, it's stuff like this that's going to prevent you from having to buy an extra 4 or 5 of them at the very end in order to bridge that gap, and that's significant savings right there. And so with that said, thank you all very, very much for your attention.